Hi, welcome to Viday Sketra, Empowering the Future. Myself, Sreenivasulu, I am a member of this particular digital platform, and on this platform, I am going to teach mathematics related courses. And today, I am going to teach the topic quadratic equation for IIT, JEE Mains, and Advanced exam. And also, it will help you to score well in EAMCET and Telangana EAMCET and other competitive examination. And quadratic equations, when I say quadratic equations, sometimes I will be using quadratic equation, or sometimes I will be using quadratic expression. The difference is very simple. Quadratic equation means, if I consider the general form, ax square plus bx plus c is equal to 0. This is quadratic equation. And when I consider this without equality and up to this only, this is quadratic expression. So if I don't consider equality, it is quadratic expression. If I consider equality, it is quadratic equation, right? You may be wondering what is the difference between quadratic equation and quadratic expression. How does it matter? It matters. Quadratic equation will give you roots and solutions. Quadratic equation will talk about roots and solutions, whereas quadratic expression will tell you the nature of that particular function. The quadratic expression, whatever you are considering, that is some function of x, that is some polynomial, right? So quadratic expression will tell you the nature, about the nature and the other details of the function, right? So let us see in detail. So this is the general expression, ax square plus bx plus c is equal to 0, where the symbols that we use here a, b, c, apart from x, these three are real numbers. This is very important. A, B and C must be real number. They cannot be complex numbers. A, B, C must be real numbers, right? Where another restriction, another condition is A should not be equal to 0. Always A is not equal to 0. What happens if A is 0? What happens if you violate this condition? If A is 0, this expression will become something like this. Bx plus c is equal to 0, which is no more quadratic equation. This is a linear equation in x. Linear equation of x, which is not our interest here. We are not interested on this. Our interest is on quadratic equations only, right? So A must be non-zero. A must be non-zero. So, and other constants b and c, they should be a real number, right? So now, if you see ax square plus bx plus c is equal to 0, this is a general form. And how does it matter? So a is not equal to 0, that means a greater than 0, or it can be a less than 0. So I'm not saying a is always positive, and I'm not saying a is always negative. I'm just saying a is not equal to 0. So that means a can be greater than 0 and a can be less than 0. So now what happens if a is greater than 0 and what happens if a is less than 0, right? This has very, very, very high significance here in the analysis of quadratic equations and quadratic expressions, right? Thing is that it's not like the questions on quadratic equations are always based on roots and solutions. There may be questions on, so if you write, there may be questions on roots. There may be questions on, when I say roots, to find the roots, the nature of the roots and all. There may be questions on solutions. There may be questions on logarithm terms. The questions may contain trigonometric ratios. Also, the questions may be based on probability theory. Okay, and in all these things, you may have to deal with quadratic equations, right? And there are questions in the recent times. So recent times, you can check the previous year question papers on in JEE Main, right? So there are questions on where quadratic equation concepts are used, and the main topic was probability theory. You can check repeatedly they are giving, right? So which means that it's not enough if you focus on a few topics alone. If you may feel that 100% I focused on these topics so that I can score well, yes, we are not discouraging you, but if you want to score very well, if you want to really get admission into IITs and NITs, you should never miss any particular topic here, right? So the question papers are framed in such a way you should never miss any topic, right? So that means if you don't know quadratic equation, if the question is on probability theory, gone, you cannot answer that question. Similarly, there may be a situation if you don't know quadratic equation, if you don't know how to solve, how to apply the concepts of quadratic equations here, even if the question is on trigonometric ratio, you cannot answer, right? So that means you should be perfect in all the aspects, in all the topics. Okay, and let me come back here. We are saying that a is greater than 0, a is less than 0, right? So it plays role when you are the value of a plays crucial role when you are finding roots of the equation. At the same time, value of a, in particular the sign of a, is very important to decide the nature of the root, the nature of the function. When you talk about quadratic expression, the sign of a is very important, how that function is behaving, right? So that let us see. So as I told, a can be positive and a can be negative. What happens if a is positive? Let us see what happens if a is positive. Let me draw a line which represents my 0 axis or x-axis. When I say 0 axis, I mean that if my function intersects with this line, that means the function value is 0. Okay. Now what happens when a is greater than 0? Since the power of the given quadratic expression, the highest power is 2, when you plot the function f of x, ax square plus bx plus c, you will get the shape of the function something like this for all possible values of a, b, c. And the points where, this is parabola, the points where the function f of x intersects with 0 axis are called the roots of the given function. And here I am designating the roots with alpha and beta, and this is the case when a is greater than 0. And now let us consider the other case where a is less than 0. And once again, your function, this indicates f of x, and here also this indicates f of x. Your function once again intersects with 0 axis, and once again these are nothing but roots of the given f of x equal to 0, the quadratic equation. And let me designate, this is gamma, this is delta. Okay, so now it is very clear. After observing these two figures here, you can realize when a is positive, the function is concave in shape and faces the upwards, the 0 axis. When a is negative, still the function is concave, but it faces downwards, the 0 axis. And as it is mentioned in the beginning, the sign of a plays crucial role on the nature of the function. This is how. Okay. Still, there are other parameters here which are related to your quadratic equation, which decide the shape of, not the shape, the position of your, this concave curve. So here the position is more than 80% is on top of the 0 axis. Very little portion is below the 0 axis. Here if you see, the position is 50% of it, almost 50% of it on top of the 0 axis, positive side, and 50% is on the negative side. Right, so this position, whether it is moving towards the upper side or downward side, it depends on the other parameters which I am going to discuss very shortly, and that parameter is called discriminant. I am going to discuss it. And before that, these are once again I am saying the questions may be on all these topics. Okay, so we are going to see all these things in this particular lecture. And before that, I just want to give you the list of the things which we are going to walk through in this particular course, in this particular chapter. First of all, we are going to start with considering nature of the roots, and then we will see transformation of QE, quadratic equation, and then we may consider common roots. After that, maximum or minimum or maxima or minima of given quadratic expression. Location of the roots, blah 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 blah. Right, so there are various topics where which we are going to consider here. Right, we are going to start with the nature of the roots, which is very important, and always it is expected questions on nature of the roots. Once again, transformation of quantum in quadratic equations, this is also very important. Common roots, once again you may expect questions on this. Maxima or minima, yes, still you can get questions. And location, here and there you may have questions, right? So but as I mentioned, no topic you can leave, right? You have to consider each and every topic equally, then only you can get the success, right? So let us proceed with nature of the roots. Right, nature of the roots. As I mentioned, nature of the roots depends on basically the coefficients of various terms in the given quadratic equation. Right. So before proceeding in detail to consider nature of the roots, let me talk about something about the basic approach to solve the given quadratic equation. Then once I complete this, then we can clearly consider nature of the roots. Let us consider this simple quadratic equation. X square plus x minus 12 is equal to 0. So the question is like, solve the quadratic equation x square plus x minus 12 is equal to 0, right? There are multiple approaches to solve this problem. There are two methods. Let us see method 1, which you used to use in your high school, which is based on factorization. Where you will be multiplying the coefficient of x square and the constant term c, and for that, for the product, you will be considering the factors here. Now if you see, the constant term is minus 12, that means coefficient of x square term is 1, and if you take the product, it is minus 12. For minus 12, what are the various factors you have? Starting from minus 1 into 12, or it may be minus 12 into 1, it may be minus 2 into 6, it may be minus 6 into 2, it may be minus 4 into 3, it may be minus 3 into 4. That's all. Now, when you should select one factor pair among these, so that when you add up those two factors, you will be getting the coefficient of x here. The coefficient of x is 1. So right from the top one you can start. This is well-known approach, but still I just want to make it very clear. Yeah. So you can start with this minus 1 and 12. When you add up those two, you are getting 11. And minus 12 and 1, when you add up those two, you are getting minus 11. So both these are ruled out. The third one, minus 2 and 6, when you're adding these two, you are getting plus 4, ruled out. Minus 6 and 2, minus 4, ruled out. Minus 4 and 3, minus 1, still ruled out. Minus 3 and 4. Minus 3 plus 4 is equal to 1. So it is matching. So you can write the equation as x square plus 4x minus 3x minus 12 is equal to 0. So you can take x common, x plus 4, and you can take 3 common, minus 3 common here. Once again you will get x plus 4. So now x plus 4 is common, x minus 3, x minus 4, x plus 4 into x minus 3 is equal to 0 you will get. And this is true only when either x plus 4 equal to 0 or x minus 3 is equal to 0. Now if x plus 4 is equal to 0, it implies that x is equal to minus 4. If x minus 3 is equal to 0, it implies that x is equal to 3. So you can write like x is equal to minus 4, 3. So this is the solution for this given quadratic equation. X is equal to minus 4, 3. So number of roots is 2 and number of solutions is also 2. This is the basic approach, right? Basic factorization approach. Now the question is, I told number of roots is 2, number of solutions is 2. Is it like number of roots and number of solutions may be different for a given quadratic equation? Yes, number of roots may be different than number of solutions sometimes. Okay, so the exception you can see here. I will give you one example here itself. Once again, we are considering one simple quadratic equation where this is very straightforward. You can write this as x square minus 2 into 2x plus 2 square, which is nothing but x minus 2 whole square, which gives you s is equal to 2 comma 2. Very simple, very simple. Okay, and here the roots are 2 comma 2. The roots are 2 comma 2. Right. Now, what is the number of roots here? Is equal to 2. What is the number of solutions? Number of solutions is equal to, it is not 2, it is 1. Okay. Why? Because number of solutions is always nothing but number of distinct roots of the equation. In this case, number of distinct roots is 1. 2 is repeated here, it's not distinct. So number of solutions is equal to 1, number of roots is equal to 2. For example, you may have one equation something like this: x power 6 plus 5x power 4 plus 10 is equal to 0. Some polynomial is equal to 0. So looking at the polynomial, how many roots you can expect? Yes, the number of roots is equal to the highest degree, the highest power of the given expression. The highest power is 6. So the number of roots is 6. And suppose that the roots are 1, minus 1, 2, 2, 2, 3. 6 roots. 1, minus 1, 2, 2, 2, 3. Now, what number of solutions? Solutions are 1, minus 1, 2, 3. So we have to, when you are writing solutions, you have to consider the distinct root once only. So the number of solutions here is 4. The number of roots is 6. Okay, so just we used number of roots here in order to convey that. I gave this example here. Okay, so this may help you. So this is about the basic approach to solve the given quadratic equation, which you have been learning from your high school, right? And now the question is, will it be helpful to solve the given quadratic equation always? The answer is no, because sometimes the solutions may be, the roots may be irrational. Sometimes the roots may be complex conjugates. In that case, the straightforward approach, the basic approach, factorization will not help you. You have to go with another approach, which is formula based, right? Let us see how to proceed using that formula and what is that formula. And it is always advisable to go with formula. Approximately the time that takes to calculate using both the approaches is the same. So the formula is, if the given quadratic equation is ax square plus bx plus c is equal to 0, according to formula, the value of x is given by x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So if you see the formula, it may look lengthy, but it is very simple. You have been using the formula, right? So no need to get scared looking at the formula. Why? Because all the terms that we use in the formula, you have here in the given equation. B is there as a quotient of x. A is there as a quotient of x square. C is there as a constant term. Only thing is that you need to remember this. And once again, when you got to remember such things, don't try to mug up. You keep on practicing the problems, then you will remember automatically. Don't try to mug up like this. Minus b plus or minus square root of b square minus 4ac by 2a. No. Please try to practice as many problems as possible. Then only you will remember. Fine. So now this is the formula for the root of the given quadratic equation, right? Where you have a strange term here, b square minus 4ac, and this term has very high significance, and this term is called discriminant. Discriminant of the quadratic equation. And compact form, in the compact form, we represent discriminant as capital D, with capital D, right? Discriminant plays a very crucial role in the solution of your quadratic equation. Okay, you need to be focused when you are considering calculating discriminant. You should not do any mistake. One silly mistake when you are calculating discriminant will result in completely different and wrong answer for the given problem, right? So please be serious when you are calculating discriminant, right? So now using this formula you can calculate, right? So what is the equation that we used few minutes ago? X square plus x minus 12 is equal to 0, and for this, if you recall, we got the solution as minus 4 and 3, right? Let us see whether we are getting the same answer using the formula approach. It doesn't take more time. It will take almost the same time what we did using the straightforward approach. Yeah. Now, before proceeding, let us note down the coefficients. A is equal to 1, coefficient of x square, b is equal to 1, coefficient of x, c is equal to minus 12. Let us calculate discriminant. Square root of b square minus 4ac is equal to square root of 1 square minus 4 into 1 into minus 2 minus 12. This is equal to 1 plus 48 square root of 49, which is equal to 7. And now if I consider the solution here, x is equal to minus b, that means minus 1 plus or minus square root of d 7, sorry, d is 49, I'm sorry, d is b square minus 4ac, d is 49, so d is 49 by 2a, 2 into 1, which is equal to minus 1 plus or minus 7 by 2, and which gives you 6 by 2 or minus 8 by 2. Minus 1 plus 7 is 6, 6 by 2, and or minus 1 minus 7 is minus 8 by 2. Okay, and this is equal to 3 or minus 4. So these are the roots. The same roots we got here also, minus 4 and 3. So there is no difference when you compare the methods, right? And which takes approximately the similar time, right? But it is always advisable to follow this method. The reason is very clear. Sometimes this will not help. Okay, so let us see that case where it's not going to help you. So if you see that, then you will realize why that method is not advisable always. Let us see. So I'm going to give you another example here where that factorization method is not going to help you. X square plus 2x minus 12 is equal to 0. X square plus 2x minus 12 is equal to 0. So let us see why we cannot use here. Why we cannot use factorization approach here? The reason is very simple. What is the product of x square term and minus 12? Minus 12. What are the available factors here? Minus 1 into 12, minus 12 into 1, minus 6 into 2, minus 2 into 6, minus 4 into 3, minus 3 into 4. Is there any combination which gives you the sum as 2? The answer is no. Okay, hence it is ruled out. You cannot. There are other alternatives to proceed further, but that will complicate, right? So the best approach is to use the formula here, right? So if you use the formula, x is equal to, so before that let us calculate discriminant. A is equal to 1, b is equal to 2, c is equal to minus 2. Always remember, as I told, you should take these values correctly from the given data. If you take any mistake, that will give you completely wrong answer, including signs. You should take correctly, right? Now d is equal to discriminant. D is equal to b square minus 4ac, which is equal to b square is 4 minus 4 into 1 into c is minus 12. So 4 plus 48, which is equal to 52. Which is equal to 52. Right. Now let us apply the formula. X is equal to minus b plus or minus square root of d is 52 by 2a, 2 into 1, 2. So this is equal to minus 2 plus or minus 52. How can I write? What are the factors? Square root of 52. First of all, is it a perfect square? The answer is no, it's not perfect square, right? So what are the alternatives, right? So you can reduce the complexity by factorizing 52, right? So for 52 we have multiple combinations to get 52, right? So what are the factors? So I can multiply, I can write 52 as 4 into 13. So 13 4s are 52, right? So I can write 4 into 13. Probably you might have understood why I am preferring 4 into 13. Yes, you are right. I am searching for some factorization where I have perfect square in the factors, right? So 4 is a perfect square, so I can write it as 2 root 13 by 2. Now this can be written as minus 1 plus or minus square root of 13. So the roots are x is equal to minus 1 plus square root of 13 comma minus 1 minus square root of 13. What did you notice by looking at these pair of roots when you compare with this simple roots? The reason is very obvious. The difference is very obvious. These are rational. These are not rational. Irrational, right? So now the bottom line is, wherever you have the chance of getting irrational numbers, then the factorization approach is not applicable. You have to go through the formula based approach, right? So you got irrational roots here, right? And one more important summary here, which I'm going to give you. Whenever you get irrational roots, something like this, 1 plus, if you have calculated, if you come to know that one of the roots is 1 plus root 3, and if you are asked to, such question may be there in the exam. For a given quadratic equation, one of the roots is 1 plus square root of minus 1 square root of minus 1 plus square root of 13. What is the second root? You need not compute. You need not even put your pen on the paper. If the one root is minus 1 plus square root of 13, obviously the second root will be minus 1 minus square root of 13. This is very, very, very important result. In general, if I say p plus square root of q is one of the roots, the second root must be p minus square root of q. You need not calculate. Or if they give you, if one of the roots is p minus square root of q, the other root is p plus square root of q. It is similar to your complex conjugates. It is not complex number, but anyways, they are antisymmetrical, right? So p minus root q and p plus root q, a plus root b, a minus root b, m plus root n, m minus root n, 1 plus root 2, 1 minus root 2, right? Whenever you get such combination, you need not calculate. Directly you can give the answer. This is true in all the cases, right? So under such cases, you cannot use your basic straightforward approach of factorization. You have to go with discriminant, right? And as I told, discriminant will decide the nature of the roots. Discriminant will decide the nature of the roots, and partially the value of a will also play a crucial role when you are deciding the root. Okay, so I'm going to give you those details also. Now we are going to start the nature of the roots. I hope you got it. Please subscribe the channel, and please you may comment in the comment box. You may have whatever the doubt you have, you may ask, you may comment, so we will try to address whatever the query we have. Now let us see the first aspect of this topic, nature of the roots. Nature of the roots. Okay, it is clearly, nature of the roots is clearly depends on the value of discriminant. So he is the hero. Discriminant plays the crucial role when you are deciding the nature of the root. Okay, so as we have seen multiple cases, right? We have seen the case where D is a perfect square. We have seen the case where D is not a perfect square. There may be cases where D is less than 0, There may be cases where d is equal to 0, right? So there are multiple cases where we may consider d, and each and every case has impact on the solution, right? So the three cases are: case 1, d is strictly positive. When I say strictly positive, I mean that d is greater than 0. No equality involved in the expression. So d is greater than 0, right? When d is greater than 0, it implies that the roots are real and distinct. Real and distinct. The roots are real and distinct. And in this case, the roots are real and distinct. Few minutes ago, we have discussed the number of roots and the number of solutions will be the same. Why? Because you are saying roots are real and distinct. If we have distinct roots, the number of roots will be equal to the number of solutions, right? So that means your b square minus 4ac will be greater than 0. Okay, which means that the square root of d, the square root of discriminant will be positive. If you have positive value under the square root, obviously the results will be real, right? This is the impact. Now, case 2. D is equal to 0. D is equal to 0. So if d is equal to 0, it implies that the roots are still real. The roots are real and similar, or you can say equal. The roots are real and similar, or the roots are real and equal if d is equal to 0. Very simple to verify. X is equal to, you know that, minus b plus or minus square root of b square minus 4ac by 2a. What happens when d is equal to 0 here? When you put d is equal to 0, this expression will simply becomes minus b plus or minus 0 by 2a, which implies that minus b by 2a. That means in this case, x is equal to minus b by 2a minus b by 2a. Why? Because minus b plus 0 by 2a and minus b minus 0 by 2a. In both cases, you will be getting minus b by 2a. Right? So roots are real and roots are equal. This is how you can understand. Now, case 3. D is equal to, d is less than 0. That means that d is negative. If d is negative, it implies that the roots are complex numbers. For the time being, I am avoiding that. Conjugates. They are complex conjugates, obviously, right? I just want to excite you by giving some result where if the d is negative, obviously the roots will be complex conjugates. That means if you come to know that one of the root is a plus ib, the other root must be conjugate of this, complex conjugate of this, a minus ib. Few minutes ago we have seen p plus root q and p minus root q. The same concept is applicable here also, right? So if d is less than 0, the roots are complex numbers. That means within the square root, you are going to get negative number. So within the square root, if you have negative number, obviously the result will be a complex number. Okay. So you can try, you can try this equation. X square plus x plus 4 is equal to 0. X square plus x plus 4 is equal to 0. You can try this equation. So you will be getting d as negative. Okay, you can try. So d is equal to, in this case, d is equal to b square minus 4ac, b square minus 4ac. So this is equal to 1 minus 16. 1 minus 16, which is equal to minus 15, which is negative, right? So if I substitute here to calculate x, so minus b minus 1 plus or minus square root of minus 15 by 2, which is equal to minus 1 plus or minus I into square root of 15 by 2 you will get. Okay, so where I is nothing but square root of minus 1, complex identity we call, right? Okay, so you will get such situation where d is negative, right? So here you can even see here the roots are minus 1 plus I square root of 15 by 2 and minus 1 minus I square root of 15 by 2. Clearly the roots are complex conjugates. 1 minus 1 by 2 plus square root of 15 I square root of 15 1 by 2 15 by 2 minus 1 minus I square root of 15 by 2. So roots are complex conjugate, right? So this is very important. To summarize, d affects the nature of the roots. If d is greater than 0, roots are real and distinct. Very important. If d is equal to 0, roots are real and equal. If d is less than 0, roots are complex numbers. Okay, so with this I'm going to conclude here. So whenever you have a negative value of d, you are saying that roots are complex conjugates, which means that there are no real roots exist for that quadratic equation. Okay, which means that there is no real number where when you plot that parabola, there is no real number that it is going to touch the 0 axis, right? And this concept we will be seeing, I will be explaining, I will be continuing the nature of the roots in the next video. Thanks for joining. Have a great day ahead.